So we're going to talk about.
Thank you.
We're going to talk about. Thank you. We're going to talk about new replica types which are being introduced in Solr 7. So this is quite a big change. Like Solr Cloud was introduced in 4.x, and finally in 7.0 we are adding 2 new replica types. So there are actually 2 talks around this. There's one today, and there's one tomorrow by Thomas, who's sitting there. You guys are invited to check out both of them because we have kind of different perspectives on the content. So with that, I'll give it to Dart, who is going to talk about the first kind of new replica. It's called the T-log replica, and he's going to talk about the motivation behind it and why we introduced it, what does it do, how is it different than the current Solr Cloud replica types, and then we're going to do a very small introduction into the other new replica type that is being introduced, and then we're going to talk about the consistency aspects of these new replica types versus what is there right now in Solr Cloud. All right, so over to Dart.
So one funny thing about the new replica type is, in first place, we did not intend to build a new replica. We just tried to solve a problem in recovery process of Solr Cloud, and it led us to the new replica type. Okay, so what is the problem? So in sort of right now in Solr Cloud, if a replica go down and miss more than 100 updates, it must download the entire index from the leader when it coming back. So let's take a look in the detail of that problem. For example, we have a collection with 1 shard and 2 replica, as you can see here. So as you may notice here, although all replica has same index, so same number of documents, 200 documents in this case, and the underlying segment of files are not the same because of many factors like RTG, magical, soft commit, the merge policy, and reordering request. And so, for example, when the replica go down and we index more documents, more than 100, when the replica come back, it have to delete its index and download all segments from its leader. So its data cannot be reused, right? Okay, some animation. And the second step is downloading the entire index from the leader. And it's not good, right? As you can see through the animation, it is very slow process. And how to solve this problem? We had many discussions to solve this problem, but it seems if we still keep the current process of indexing in replica, we can't solve this problem. So it led us to a design of new replica mode called T-log replica. So what is T-log replica? So in the new mode, only leader do indexing, but it still forward update to its replica. But replica will only append update to the T-log, and the replica will periodically pull new segment from the leader. When replica go down and come back, it only have to download the missing segment from the leader. Okay, so let's take a look in detail, and you will understand the process better. Previous slide. Yeah, it's still the same today.
You're saying it does do that?
Yeah.
Okay.
So, for example, we still have a collection 1 shard and 2 replica. So when we index a doc, leader will index that doc locally and append the document to its T-log and send out that document to the T-log replica. The T-log replica will append that document to its T-log without index that document locally. As you can see here, the replica do not have the rectangle index doc1. And when we index more document, the process will be still the same and documents stay in the leader buffer. So in short, the leader will behave the same nowadays, just the T-log replica acts different. So when we do a commit, the replica will pull the new segment from the leader, okay? And
so the segment, yes, the segment does go over in binary form. So the segment is completely indexed and built on the leader, and then it's basically very similar to how the master slave used to work. So it's the same model.
okay. So after pull the new segment from the leader and replica, we have the same index, right? 10 documents in this case. And so what happens if the leader go down? What about the recovering process? So let's take a look. For example, we index more document, and the leader go down. But because the T-log replica have doc 11 and doc 12 in its transaction log, the replica can replay each transaction log and become the new leader. So we do not lose any documents. So for example, the new leader receive more update and have one more segment. So when the old leader come back, it only have to download the missing segment without removing its old segment, right? Because the old leader and the new leader have in sync in segment level. So it only has to download the missing segment and reuse. So in this case, the old leader can reuse its segment 1. So that's all the process about the indexing and recovering process. So I hope you will get a sense about how new replica most work and why we need a new replica most. So Shalin will talk about the pros and cons of the T-log replica.
So for the new leader, who will initiate the segment creation? Because the data is now in T-log. So the question is, for the new leader, who will initiate the segment creation? Is that the question? So, the new leader actually has some pre-built segments which came from the old leader, and it also has uncommitted documents in its transaction log. So when it needs to become the leader, it has to first replay those transaction logs locally into a new segment, and then it can become the leader. And then any more documents that come in as updates, it just needs to keep on creating new segments. So the old leader, when it comes back, it downloads those new segments from the current leader, and then yeah. There's a question there. Can you repeat that? So the segment merges are not really kept in sync as such. I mean, there's no synchronization as such. But if you look at, so if you're familiar with the master-slave replication that used to be there in Solr, it's the same. It's exactly the same code. So if the merge creates a new segment on the leader, then that whole new segment is copied over to the replica, and the old unused segment is cleaned away. No, because there's no indexing happening on the replicas at all anymore.
Okay.
So now that we know about the T-log replicas, the main difference here is they do not index locally. They just add the documents, the updates to the transaction log, and then send an acknowledgement to the leader. There is a third kind of a replica type. So like the current one, which we all know about in Solr Cloud, that is what we call as the near real-time replicas, or the NRT replicas in short. These NRT replicas have a transaction log. They also have their own index. Indexing happens on the leaders as well as on replicas. In this one, indexing only happens on leaders, not on the replicas, but the updates are still actually sent to all the T-log replicas because they have to put it in the transaction log. The third kind of replica type is what we call as the pull replica type. The pull replica type is even more simpler. It does not have a transaction log. It does not write to its local index. All it does is periodically go to the master and say, hey, what are the new segments since I last talked to you? Give them all to me. So it's like plain and simple master-slave replication, no T-logs, nothing. So one really good thing about this pool replica is that first, the indexing throughput is not affected by the number of replicas that you add, because the leader does not have to talk to the replicas as part of the indexing request anymore. It's an asynchronous pull-based replication which happens behind the scenes. So the indexing throughput is not affected. If you have used Solr Cloud at scale, you might know that there is like a 15 to 20%, sometimes even more performance degradation as you keep on adding replicas for a given leader. And that happens because for each request that goes to the leader, it has to send those same updates to all the replicas, and then wait for an acknowledgement before sending an acknowledgement back to the user. That is not the case here. For the T-log replica, though, that is still the case, although it's a bit more faster now because the T-log replica is not writing to an index. It's only appending to a T-log, which is a much more faster operation. There's no analysis, nothing being done there, right? There's no commits to be done. There's no merges to wait for, et cetera, et cetera. The downside for pull replica is they can never become leaders. So the T-log replicas can become leaders, but the pull replicas, since they do not have a transaction log, we do not have a way of guaranteeing the consistency of the data, so they can never become leaders. So which means that in any cluster where you want to use the pull replicas, you need to have at least a few T-log replicas or NRT replicas, and only then you should use pull replicas. Otherwise, you do not get the benefit of the master failover, the leader failover, which happens automatically in Solr Cloud. So how do you, and of course, because they do not have a T-log, we cannot support real-time gets on these replicas anymore. So no real-time get on pull replicas, although real-time get is still possible on the T-log replicas, but there are some caveats to that, which we'll discuss in a couple of slides. So now that we know about there are three kinds of replicas, how do you actually create a collection which uses these different kinds of replicas? And that's fairly simple. The create collection command API has three new parameters: NRT replicas, pull replicas, and T-log replicas, which they mean exactly what you think it is. The old way was to say num shards equal to X and then replication factor equal to Y. In this new case, if you use replication factor, it's basically the same thing as saying NRT replicas equals to Y. Basically, replication factors and NRT replicas, they both create NRT replicas. So let's do a very quick recap. So NRT replicas are the replicas which you are already familiar with. They have been in Solr Cloud since 4.x. They have an index, and they have an T-log. The T-log replicas, new in 7.0, only have a T-log. They do not write to their local index. They just fetch fully built index segments from the current leader. And the pull replicas don't even have a T-log at all. So now let's look at the consistency aspect. So obviously, with like everything, there are trade-offs here. We gain some things, we lose some things. So what do we lose and what do we? So we have kind of covered about what have we gained here, but what have we lost? So let's look at the indexing side and the querying side. Real-time gets are interesting, especially when delete by queries are involved. So let's take a look at them. So when you have replicas, the NRT type replicas, or the normal replicas that were in Solr Cloud until 6.x, a replica which is an active state, it's always consistent for querying after an explicit commit. If you are using auto commits, if you're not sending commits by yourself, auto commits happen on their own schedule on the leader and on the replicas. So there might be periods of inconsistency because depending on when the commit actually was scheduled on the replica, it might not exactly have the same documents as the leader. But they are still eventually consistent. If you stop indexing, after a certain amount of time is gone, the auto commit kicks in, and then you will have the same number of documents everywhere. For real-time gets, they are always consistent. If you add a document, as long as you got an acknowledgement and the replica is in active state, you will get back that latest document always. If the replica is in recovering or the down state, then we do not provide any consistency guarantees. There is another case which is not covered here. It is a case where the replica has lost its connection to Zookeeper. If you query Solr today on Solr Cloud, as part of the status in the request, you get a parameter which says zk connected equals to true or false. So if zk connected is true, then you can be reasonably sure that this is the current most up-to-date data. But if it is not connected to Zookeeper, then all bets are kind of off. So this is another caveat that is not very fully known, but it's there. Coming to the T-log replicas, a replica which is in active state, it is eventually consistent for querying even if you do an explicit commit. So an explicit commit does not guarantee consistency on T-log replicas, but it does on NRT replicas. This is because the commit is kind of a no-op on the replica because we never modified the index at all, right? So there's nothing to commit. All it can do is wait for the commit to complete on the master, and on the next fetch cycle, copy over the segments from the leader and install them on the local disk, right? And then reopen the searches. So even in the face of explicit commits, the T-log replicas are eventually consistent. The same thing goes for auto commit as well. The time lag is kind of small. It's not very large. By default, the poll interval between fetching new segments is half the auto commit if it is configured. I think if the auto commit is not configured, it is like, what, 5 seconds? 3 seconds? Yeah, so by default, it does for 3 seconds. But if you have an auto commit for, say, 2 seconds, then it will fetch every 1 second. So it's half the auto commit time. It is always consistent for real-time gets. Yes, but the big caveat is if you use delete by queries, then this cannot be guaranteed. And the reason is the way delete by query works. So delete by query is actually a very, very interesting feature. When you send a delete by query to a replica, it purges its local cache of uncommitted documents. And it opens, it basically does a soft commit underneath, and it opens a new real-time searcher, which has a completely up-to-date view of the current index, right? And because the cache of the T-log is completely purged away, so every time you do a real-time get, you're actually hitting the index instead of the T-log, okay? But that cannot be done here in the T-log case because the index itself does not have the new documents. Like, by definition, they're uncommitted documents, right? They're only in the T-log. So we cannot do anything. It's basically like a no-op, which also means that if you do a delete by query, which deletes a document X, if you do a real-time get on the leader, you will not find document X. But if you do a real-time get on the T-log replicas, then you will find that document X because it cannot be deleted. Once it does a fetch and once it applies the latest index from the master, then it will become consistent. But until that time, with delete by queries, it cannot be consistent. This comes to I come to the related point, the soft commits cannot be supported on T-log replicas, right? Because, well, with the soft commit, you are basically, you don't have any uncommitted documents on the replica anyway. So a soft does not do anything, right? It does not have anything to commit at all. So it cannot make things visible as fast as you could do on the NRT replicas. So this is the trade-off. You cannot have very fast turnaround times if you are indexing documents with T-log replicas. But because you're separating out the indexing and the searching part, you can get better throughput, better utilization of caches, and stuff like that. Again, a replica which is in recovery or downstate, you cannot rely on that to give consistent answers. So this is the same as the NRT replicas. Now, what happens with pull replicas? A replica in a pull replica in the active state, it's eventually consistent. Even after an explicit commit, it is eventually consistent. Even if auto commit is configured, it does not support real-time gets at all. So if you want to do a real-time get, you have to talk to the leader. So this is something that we can improve in the future. So we can probably add a way of routing a real-time GET request to the leader always. We don't do that today. So you have to like explicitly figure out the leader and send a real-time GET there. But then cases where pull replicas are most useful are usually use cases where real-time GET is not used that much. People who have huge amounts of replicas are going to use this. E-commerce players are very interested in something like this because it separates out indexing and querying. So they're very interested in that. Real-time GETs are not very useful cases. But then you can mix and match replica types. You can have a few NRT replicas which offer real-time GETs, and then a large number of pull replicas which do not. So this is something that we need to improve. We need to add some sort of a routing mechanism to these kind of requests so that we either go to the leader, or we go to the T-log replicas. So when to actually use these T-log replicas? So the trade-offs, now we all know, we can just quickly recap it. You have to use T-log replicas where query performance is more important than the near real-time turnaround times. You have a small number of replicas. So remember, this is still the same case where an update that goes to the leader has to be sent to all the T-log replicas. So if you have like 50 T-log replicas, that's probably not going to work very well, right? So you have a small number of replicas. You obviously need redundancy on the leader. If the leader goes down, you want somebody else to take up that role, and your indexing should keep on going. Real-time GET is important or essential. Delete by query, however, is either not needed or it's done so rarely that consistency is not really an issue. Like, for example, you blow away the index and start re-indexing again, stuff like that. You have to use pull replicas where query performance is paramount. That's the most important thing that you care about. You don't want indexing happening at all. Your indexing throughput also is very important. You don't want to have like 50 replicas slowing down the indexing process. So you still want to index fast and you want to query fast. But real-time GET is not required at all because it cannot be supported. So the best practice here is, well, first of all, you should not try to mix NRT replicas with these other types. And the reason is very simple. Because NRT replicas index on their own, they update their own index all the time. If the old leader goes down and another NRT replica becomes a leader, it suddenly has a completely new index with completely new segments, which do not match the segments on any other pull or T-log replicas. So every T-log or pull replica, or for that matter, any other NRT replica will have to download the whole index all over again. You don't want that, right? That's the reason why you went for a T-log or a pull replica. So don't mix them together. Either have all NRT replicas as you were doing today with Solr 4 or 5 or 6.x, or you have a small number of T-log replicas and then probably a large number of pull replicas depending on your query performance requirements. T-log replicas will provide both leader failover and the ability to do real-time GETs. And so, for example, if you want an example collection can have like 3 T-log replicas, so like 3 replicas which can become leaders. So you have redundancy in terms of writes, and then maybe 10, 15, or 25, depending on your requirements, number of pull replicas which help you with your query performance. So that is actually pretty much it. So I think we have plenty of time. We finished quite early, so I'm happy to take questions. Yes?
So another node is made as the leader, but it never got the delete. So the delete will be completely lost.
Yes, you're right. So the question is, if you do a delete by query on the leader, but before a commit happened, before the new segments were transferred to the T-log replicas, the leader went away, and the T-log replica now becomes a leader. It has no idea that the delete by query happened.
No, it have, because the delete by query
yes,
also
right.
append to
of course,
the
you're
T-log.
right. So the delete by, I'm sorry, yes,
Yeah.
you're right. The delete by query is actually stored in the T-log. So when it replaces the T-log to become leader, it will actually replay the delete by query. So yeah, it's not lost. It's there.
And is there a way to know that it is consistent or not consistent at this point from the replica?
No, there is no API like that. You can still use the, if you have used the admin UI, there's a version which is the searchable version, the replicatable version. So you can compare both of them, but there is no easy API to tell you that they are consistent.
The replication API doesn't tell that.
No, the replication API does tell that. It just gives you the version, so you have to like go against the master and compare it to figure out whether it's consistent or not. Yes. No, it's not something that you can like directly eliminate. It's probably like a network, issue. But because you have the T logs, we still figure out what update is out of order.
You never get an out of order index. You never get a version number actually committed into an index that is out of order. Before that was a problem.
So
Because now you're actually pulling segments.
it is possible, but the point is if you have a version on the T-log replica, when you try to replay it, if it sees that it's an old version, then it's a no-op. It won't actually do anything on the index. So it's all the same code that works currently on the NRT replicas, which deals with out-of-order updates. There's no changes to that. So it still continues to work because we have a T-log.
So, say we're using the full replica, or even not the NRT, the other replica, T-log replica. If they're periodically checking for new segments from the leader, and say, our interval is 3 seconds, if it's a large enough segment and the transfer takes longer than 3 seconds, is it going to start?
No. It actually has to wait for that, for the fetch to complete before it tries to do the other one. Yes.
For running this, do you find there's a difference between the number of CPU size of memory, et cetera, between a T-log replica and a full replica that's needed for?
So we haven't got around to benchmarking it yet, but if you we know that a lot of work is being avoided on the replicas because it's not indexing anymore.
Right, exactly.
So we assume that the number of I/O cycles and the number of the CPU usage of that instance is going to go down.
Right, so I was thinking that the full replicas would probably be a less number of cores and maybe even a less overhead as far as memory.
In terms of memory is mostly dependent on the, of course, the merges are not happening and the merges take up some memory, but usually for a query heavy instance, the caches and all take most of the memory. And that continues to be there.
More memory.
So that continues to be there for the pool and the T-log replicas.
T-log and full mix-up also look like a problem to me. So if you have a few nodes with T-log and few with full, you use Solr, they connect to Zookeeper, and you are using a get query. If some of the get queries go to T, so there can be a data.
Yes. So the question is if you connect to Zookeeper and you try to do a real-time get on a collection which has a mix of pool replicas and T-log replicas, then you can get inconsistent answers. So actually, you will get an error if you connect it to a pool replica, but if you happen to connect to a T-log replica, then you'll get the right answer. So this is something that we need to improve. We need to add some sort of routing from the client mechanism, or even inside, like a proxy layer inside the Solr layer, which can go to the right node automatically.
That was one of the questions I was going to have is could I then kind of limit queries to go to just the full replicas unless it was something that had to have
So the question is there a way to limit to say, I want my queries to go only to the pool replicas? There's no way right now, but there's an issue that is being worked on in SolarJ, which it's kind of related, which says, I want to tag my nodes, and then I want to say this query should only go to nodes with this tag. And probably something like that can be adapted to be used here. Yes? The updates always have to go to the leader. So there's nothing that you can You can tag there. It's only the queries or the real-time gets which can be routed to arbitrary nodes. No, Solr only sends to the leader. The leader in turn sends it to all the NRT or the T-log replicas, waits for their answers. It happens concurrently, but it waits for all their answers, the acknowledgements, and then sends an acknowledgement back to the client. Yes? Well, the metrics, like in terms of, sorry. So he said if you have, pull replicas and T-log replicas, are the metrics going to be different? The, the JMix or the metrics API metrics are going to be different across them. So the metric property names are going to be the same. They're not going to be different, but there are obviously some metrics which are never going to get used. For example, soft commit counts and stuff like that is just never going to be incremented on the T-log or pull replicas. Yes? No, so there's no way to do that. So the question is, if you have pull replicas, is there a way to tell me that all pull replicas have got a copy of the latest document? Is that the question? Yeah? Yeah. No, there's no way to do that right now. No. Every time you fetch the latest segments from the master, the commit itself has the version of the last update recorded in that segment itself. And using that version, we can purge the old updates away from the T-logs. So there's still some like bookkeeping involved, like you have to copy over any versions that you have that are greater than the commit version. So you have to copy them over to the latest, to a new T-log, but then you can purge away the old T-logs. No, it doesn't work like that. Like basically we do a diff of the files locally versus the files on the leader, and then we copy over the stuff, and once everything is done, at the very last we write there's a segment file that you have to write which signals that this segment is ready to be used now. And only then the searcher is reopened on top of that. So you can never have holes, basically. Okay, so if that's all, then thank you all very much. I hope you found it useful. And tomorrow, Tomas is giving another talk on the replica types, and yeah. So you guys should go see that. Thank you.